Algebra 1, binomial expansion, type 3, find the coefficient. So in these questions we're going to be asked to find the coefficient of a specific term, and we have to remember that coefficient is the constant in front of the term. So in other words, constant in front of the variable. So for example, if I had 3x squared, then 3 is the coefficient. So for example, in these questions, we could be asked to find the coefficient of a cubed in the expansion 2 plus a to the power of 5. So again, we could look at that and go, well, n is equal to 5, which means that there are 6 terms. So 6 terms isn't too difficult to expand. We could expand fully and simplify, and then circle the term that has a cubed in it and write down what is the coefficient of a cubed. But in the previous type, we looked at using the general term, and that's exactly how we're going to solve these questions. We're going to again use our general term. But again, there's nothing wrong with fully expanding and simplifying that way either. So as seen in the previous video, we can find this on page 20, where it's n choose or, x to the power of n minus or, y to the power of or. So if we're looking at this question, what information do we know to sub into this formula? Well, we know that the first term in the binomial is 2, the second term is a, and n is 5. So what we're missing for this formula is or. So we say we need to know what or is. So how are we going to do that? Well, let's fill in what we do know. So we have t of or plus 1. N we said was 5. The first of the binomial terms there is 2. And then it's n minus or. The second term is a to the power of or. So if I look at that, 5 choose any number is a constant. 2 to the power of any number is also a constant. So both of these are basically a constant, where a is the variable, and therefore this constant is the coefficient of a to any power. And if you look there, there's no number in front of a, which means that if I look at its power, the power is or, but I want a cubed. So this is our hint in the question. So if I look at what or must be 3. So now I know what or is. All I have to do is sub in, wherever there's an or, the number 3. And therefore that simplifies to the fourth term. 5 choose 3 is 10. 2 to the power of 5 minus 3 is 2 to the power of 2. And 2 squared is 4. And then a to the power of 3 is a cubed. So that means that the fourth term is 40a cubed. So in other words, the coefficient of a cubed is 40. Okay, so let's look at one that's a bit more complicated, where we're asked to find the coefficient of x squared in the expansion x minus 2 over x cubed to the power of 10. So if I'm looking at that, we have our first term is x, the second term is minus 2 over x cubed, and n is 10. So again, we need to know what or is. We don't know what that is. And again, we need to look at the coefficient of x squared. But if I sub into my general term this time, what we'll notice is that we have n choose or, so 10 choose or, the first term, which is x to the power of n minus or, the second term, which is minus 2 over x cubed to the power of or. And this time, it's not so obvious, because we know that 10 choose or is a constant, so it's the coefficient. But now we have two sets of variables. So if I'm looking for x squared, I don't have the obvious x to the power of or, like in the previous question where it was a to the power of or. Here I have x to the power of 10 minus or multiplied by minus 2 over x cubed to the power of or. So what I'm going to have to try and do is simplify these using my indice rules so that I end up with x to a power, and then I know that that power has to equal 2. Okay, so let's see what I can do here. We have t of or plus 1, 10 choose or, I can't do anything with because I know it's a constant. X to the power of 10 minus or, I can't do anything with because I can't simplify that. However, minus 2 over x cubed to the power of or can be written as minus 2 to the power of or multiplied by 1 over x cubed to the power of or. And that's because, obviously, minus 2 multiplied by 1 over x cubed is minus 2 over x cubed. So all I'm doing is I'm separating out the constant and the variable. If I then look at the 1 over x cubed, I want to write that as x to a power. And we might remember from junior cert that if I have 1 over x, that can be written as x to the power of minus 1. So therefore, if I look at my tables and I look at page 21, well, if I zoom in here for a second, we can see that we have 1 over a to a power p can be written as a to the power of minus p. So here it's 1 over x to the power of 1, and that's written as x to the power of minus 1. So in other words, the p is 1. Okay? So therefore, if I look at what I have 1 over x cubed. So therefore, 1 over x cubed, well, if we're looking at that formula, that's p in the formula. So therefore, that will be a to the power of minus p. So in other words, 1 over x cubed is x to the power of minus 3. So therefore, I now have t of or plus 1 is 10 choose or, x to the power of 10 minus or, minus 2 to the power of or, and 1 over x cubed can be written as x to the power of minus 3 to the power of or. And if I just shuffle that around so that I have the constants, because again, order doesn't matter in multiplication. 2 times 4 is 8. 4 times 2 is also 8. So I can rearrange these so I have the constants together and the x terms together. Well, look at this. We have x to the power of minus 3 to the power of or. And if I look at the third rule here on my indices page, well, I have a to the power of p to the power of q is basically a to the power of p q. So in other words, I just multiply these powers. So therefore, that's going to be x to the power of minus 3 times or. And now I have an x raised to a power and an x raised to the power. And if I look at my indices, page 21, that's the first rule. If the bases are the same, we add the powers. So if I look at these, the bases are the same, so I'm going to add the powers. And if I add those powers, I have x to the power of 10 minus or minus 3 or. So minus or minus 3 or is minus 4 or. So now I have my constants, and I have the variable, and I just have one variable, x raised to a power, and I know this power has to be, if I go back, x squared. So therefore this power has to be x squared. So I need x squared. So therefore that means that if I look, I need the power of x to be 2. So by equating the powers there, then I end up with 2 equals 10 minus 4or. So bringing 4or to the left becomes plus 4or, and subtracting 2 from both sides, I get 10 minus 2 is 8. Divide both sides by 4, and or must equal 2. So now I have evaluated 2 using my indice rules on page 21 of my maths tables. So all I have to do to finish off is sub in or back into this equation. So we end up with, wherever there's an or, we're putting 2. So t of or plus 1 is going to become the third term. If or is 2, minus 2 to the power of 2, x to the power of 10 minus 4 times 2. So in other words, the third term is going to contain x squared. 10 choose 2 is 45. Minus 2 squared is 4. And x to the power of 10 minus 8 is, of course, x squared. So therefore, 45 times 4 is 180 x squared. And therefore, that tells me that my coefficient of x squared is 180. So really important to be able to use those indice rules. So to summarise, we wrote out the general term. We used our indice rules to simplify, to separate out the constant from the variable. And we tidied up by getting one variable to one power. We then took that power and equated it to the power that we needed, which was given to us in the question, so x squared, so the power was 2. And then we solved for or. Once we knew or, we were able to sub back into the general term and simplify, and of course then the constant in front of the variable was the coefficient.